Hello everyone, and welcome to our course on 3D graphics programming. Thanks for joining me. My name is Gustavo Pezzi. I have been teaching computer science and mathematics here in London for quite some time now, and one of the modules that I teach in undergraduate level is 3D graphics programming. Right, and students keep saying that this is one of the most eye-opening moments that they have ever since they started learning how to program, because they always wondered, like, how are these pixels being rendered every time that you want to generate and render an image, right? How do you fill those triangles? How do you organize the vertices of your 3D model and your 3D mesh, right? How do you texture things? And this is the opportunity, right, for you to go and understand all these things pixel by pixel, vertex by vertex, triangle per triangle, object by object in our display. So, course motivations, right? Like I said, students, they come, they want to understand how things are rendered in our display, right? You have all these pixels dancing around. So how do you go and you flip the correct switches, right? How do you go and you change the colors? How do you control all these things in memory? This is my motivation, right? I want to teach the students how these things happen under the hood. And for that, I am not going to use any powerful graphics API. I'm not going to go with OpenGL, DirectX. I'm going to teach everything from scratch, right? We're going to take a trip back to the 90s, early 2000s, and understand how those things were programmed only using the CPU, right? So if you are kind of from my era, around 1993, 1994, I realized that games, they really started pushing the capabilities what we call 3D rendering. Yes, of course, right? Very flat shaded, right? Very low poly, right? Very low polygons. But I looked at games like that, for example, Falcon, right? These early simulators that you have. I was super impressed, right? The level of details, the color palette that you have, the way that they could squeeze all that little performance, right? Things rotating, shading, lighting effects. It was a very cool moment to go and be a gamer, right? I'm not a gamer anymore, but back then when it was this kind of DOS games, I was really going for it. So this is a classic example of a game that there was no dedicated graphics card, there was no GPU accelerating these things. Everything was still CPU based, right? Everything was rendered using the processor. And that is kind of exactly what we're going for in this course. So the rise of 3D graphics, right? If you think about the rise of 3D graphics, I would say that this was the era, right? Around 1993, 1994, especially when I was playing these flight simulators. And, well, of course, other titles as well, right? If you look at this one, Indie Racer from Papyrus, this was the developer. I looked at the textures, the way that they were mapping things, and even the fast performance that they got. I was super amazed at how they could squeeze everything into this 386 processor. Other examples, I think one of my favorite games that I spend more time than I care to admit, it was called TFX. This was the time that I really paid attention to these ideas of the triangles, right? This shading, different shading effects that was going into triangles, everything real time, right? So this whole idea of camera control, no GPU acceleration, nothing. So whenever we think about this modern computer graphics, nowadays, you are probably going to take advantage of these GPUs, right? This dedicated hardware. They have several cores, they can divide and conquer the tasks, right? All this parallel rendering going on. We are not going to use this thing, right? So this is not the focus of our course. We're not going to use any parallel techniques with the GPU. There's no acceleration going on. Also, remember when I said CPU-based, right? You will hear programmers say that this rendering is software-based or CPU-based, because everything is basically not being done using a GPU and is being done using the processor, right? It is CPU-based, processor-based. No graphics API either, right? So I'm not going to teach you here in this course OpenGL. I'm not going to teach you how to write using Microsoft DirectX, right? So all these little things, these graphic APIs, they are amazing. They are super productive tools, right? They know how to communicate with the GPU, how to make things in parallel processing. But again, that is not the focus of this course. The focus of this course is I want you to understand kind of how OpenGL and DirectX, they do these things under the hood, right? So it's almost like we're going to open the black box that is OpenGL and DirectX and understand a little bit of how they do things, right? How they render triangles. Whenever you say draw triangle with OpenGL, whenever you say draw line, what happens under the hood with these things, right? That is the goal of our course. So OpenGL, DirectX, all these fancy, modern, very cool graphics APIs, that's not the goal of our course either, right? So we're not going to use any of these things. We're just going to go you alone, the C compiler, the CPU, and a lot of linear algebra. We're going to make things happen on the screen, right? Just us, the CPU, and our pixel buffer on the screen. So just quick review, right? This idea of software rendering, right? Whenever you hear programmers talk about software rendering, CPU, right? There's all this CPU-based processing. Everything is happening on the CPU, instruction per instruction, right? And in comparison, you have these ideas of hardware-based rendering, right? Which is this modern approach where you have an actual dedicated card, right? You have this GPU, this graphics processing unit that goes and helps things a lot, right? They have several cores, they can divide and conquer the tasks, right? Every little core can go and process the vertices of several triangles. Not gonna use this one, we're gonna go this way, right? We're gonna go CPU-based. And if you ever took a course with me, right? I think I'm getting a reputation, but if you ever took a course with me, when I say from scratch, you know it, right? It is from scratch. We're gonna open our terminal, we're gonna open our code editor, and we're gonna start int main void, and we're gonna start from our entry door there, right? Our int main. Everything that we're gonna program, we're going to use very few dependencies, right? I'm gonna talk about the dependencies and what you have to install, but it's basically you, your C compiler, and that is what we're going to start, right? We're going to use the GNU C compiler collection, and you will see the end result of this course is nothing but amazing, right? It is incredible what we're going to achieve just by kind of squeezing everything we can out of our smoky CPU. So just a quick roadmap, right? Let's just kind of take a bird's eye view of fun things that we're going to look at. So I am going to use pure C for this course, right? Gustavo, why not C++? Why not any other modern language? It would be really good for me to use all the power of C++ and all these modern things, right? But I want to use C, mainly because I want our code to be as portable as I can. And when I say portable, I'm not talking about different architectures. I'm talking about you getting the algorithms that we coded and porting to other languages, right? So if you want to get that algorithm that draws and fills a triangle on the screen, and if you want to port to Java, to Python, to whatever other language that you want to render, it's very easy to go from C to that other language, right? It's not as easy if you use, for example, C++. It's a little bit different, right? Not every language has the luxury of having, for example, operator overloading or other fancy things that C++ provides. So by going with this minimal approach, using just C and the library SDL, I'm guaranteeing portability, right? Portability in terms of operating systems. You can use Linux, macOS, and even Windows. And also, right, you can get all these algorithms and port the algorithms to whatever language you want. Swift, Python, Java, you name it, right? You're free to go your own direction after this. We are going to talk about the foundations of 3D graphics. Very fundamental things that we take for granted. Rasterizing a line, right? Drawing a pixel on the screen. How do we fill triangles, right? How do we color an entire triangle with a solid color? How do we map textures into the triangles? So all these foundations of 3D graphics, projection, you know, the linear algebra that goes with it, that is what we're going to talk about. Setting up our application, right? I'm going to teach you how to set up your environment, regardless of the operating system. You have some libraries, you have some compilers, so no issues there. Yeah, so this is one of my pet projects, right? One of my main areas of research here at the university is to teach mathematics by using game programming. And this course is pretty much the best option to demonstrate that, right? Concepts of trigonometry, a lot of linear algebra, right? So matrices, you have these ideas of vectors. There's a lot of cool stuff from the mathematics that we can, you know, easily integrate and learn as we evolve as graphics programmers. So this is an excellent opportunity for you to exercise your chops and review some of those things that maybe you forgot from high school, elementary school, or even freshman level calculus. Also ideas then about objects, right? 3D objects, vertices, triangle faces, meshes. We have those ideas of basically controlling the pixels on the screen. We're going to have full control of all these little pixels on our screen, right? We're going to develop this idea of a color buffer in memory. We're going to talk a lot about projection, right? So we have these different types of projections. You have projection matrices, these ideas of perspective views. Rasterization is a big topic, so rendering a line, rendering a triangle. We are going to go and pixel by pixel draw our objects on the screen, right? So if you want to render a triangle, you're going to have to do some loops to go pixel by pixel, filling that triangle with the correct color. So we're going to learn some algorithms to make that possible. Handling texture, there's a very fun topic, right? Mapping textures into our triangles and all the little issues that come with them and how do we solve them using several algorithms for texturing as well. Of course, right? No reputable 3D engine works without kind of controlling camera. So we're going to learn about these view matrices. We're going to learn about cameras, these look-at transformations. There are several things, right? If you don't understand all this jargon and technical terms, don't worry. We're going to go and understand what each one of these things are. And of course, nothing will be complete without us rendering some actual complex 3D models, right? I don't want to finish this course just showing a little cube rotating on the screen. I want to load a proper 3D model, right? Maybe we load something from an external file that was generated by Blender or 3D Max or Maya. So how do we load that information from these external files that were generated by this 3D model software? So we're going to learn complex model, complex texture, lighting, shades, right? We're going to make things happen on the screen. And that's it, right? Hopefully you are on board with my plan and you agree with my roadmap. You think that's exciting as well. So in the next sessions, we're going to take a look at starting to configure our environment, right? Configuring our compiler, understanding the folder structure of our project. So let's go, dive in with me and let's have fun.